Principle of superposition. To understand this principle, we can take an example of a charge Q1 placed at a point A at a distance R1 from the origin O. O is the origin and Q1 is the charge. The distance between the origin and the charge is R1. Then you can place another charge Q2 at a point B at a distance R2 from the origin O. The distance between B and A means the distance between Q2 and Q1 can be represented as R12, means the distance of Q1 from Q2. We know the Q2 will exert a force on Q1. This is directed along this direction, and this force can be represented as F12, means the force exerted by the second charge on the first charge. By Coulomb's law, this force is given by F12 is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by R12 square and directed along BA. Then you can place another charge Q3 at C at a distance R3 from the origin. Therefore, this charge is Q3. Place a charge Q3 at a distance R3 from the origin O. We know this Q3 will exert a force on Q1. Before discussing the force exerted by Q3 on Q1, let us answer a question. The question is this one: the presence of Q3, whether the presence of Q3 will affect the force between Q1 and Q2. എന്ന് പറഞ്ഞാൽ Q3 ഇവിടെ വരുന്നത് കൊണ്ട് Q1 ഉം Q2 ഇടയ്ക്കുള്ള ഈ ഫോഴ്സിന് എന്തെങ്കിലും മാറ്റം വരുമോ? The answer is very important, and the answer is no. The force between Q1 and Q2 will not be changed due to the presence of Q3. This is a very important point with regards to principle of superposition. Means the force between two charges will not be affected by the presence of any number of charges placed near to it. This is the point number 1. Unaffected. What is unaffected? The force between two charges will not be affected due to the presence of the other charges. ഇപ്പോൾ രണ്ട് ചാർജുകൾക്കിടയ്ക്കുള്ള ഫോഴ്സ് എന്ന് പറയുന്നത് മറ്റ് ചാർജുകളുടെ പ്രസൻസ് കൊണ്ട് മാറ്റപ്പെടുന്നില്ല. ദിസ് എ വെരി വെരി ഇമ്പോർട്ടൻറ്റ് പോയിന്റ് വിത്ത് റിഗാർഡ്സ് ടു പ്രിൻസിപ്പിൾ ഓഫ് സൂപ്പർപൊസിഷൻ. Then we can come to the force exerted by Q3 on Q1. The distance can be represented as R13, the distance between Q1 and Q3. Therefore, the force exerted by Q3 on Q1 can be written as F13, that's equal to 1 by 4 pi epsilon 0 into Q1 Q3 by R13 square, and is directed along CA. The force is directed along CA. This is F13. Now, two forces are acting on Q1. The question is, what is the total force? To find out the total force, we know it is the vector sum of F12 and F13, because the forces are the vector quantities directed along these directions. To find out the vector sum, you can construct the parallelogram. Then the diagonal will give the total. The total is F1. Therefore, F1, the total force acting on Q1 due to Q1 and Q2 is given by F1 is equal to F12 plus F13. This is the second point with regards to principle of superposition. This means the force acting on a charge due to a number of charges is equal to the vector sum of the individual forces. Therefore, it is the vector sum. Then, suppose there are a number of charges, Q4, Q5, etc. What will happen? Each and every charge will exert a force on Q1. Then the total force will be the sum of the vector sum of all the forces. That means F1 is equal to F12 plus F13 plus F14 plus etc. up to plus F1n, the force exerted by the nth charge on the first charge. This is the mathematical form of principle of superposition. Therefore, the important points of principle of superposition are two. One is the force between two charges are not affected by the presence of the other charges. Then the total force is the vector sum of the forces due to the individual charges. On summing up, you will get the principle of superposition. The statement is like this: the force on any charge due to a number of charges is the vector sum of all the forces on that charge due to the other charges taken one at a time. Taken one at a time means find out F12 first, then F13, F14 and etc. Therefore, taken one at a time. The individual forces are unaffected due to the presence of the other charges. That is, F1 is equal to F12 plus F13 plus F14 plus etc. up to F1n. This is called the principle of superposition. Then we can come to the concept of electric field. I think you have studied gravitational field of the planets and masses in the lower classes. The electric field is also just similar to that. I will give the definition first. What is electric field? Electric field, it is the space. It is the space around an electric charge. Therefore, electric field is the space around an electric charge where an electric force of attraction or repulsion is experienced. Therefore, what is electric field? Electric field is the space. To make this point clear, I am taking an example of a point charge Q plus Q point charge. Then you can imagine a sphere of radius infinity. The radius is infinity. You can imagine a sphere of radius infinity around this charge. Then the space in this sphere, the space inside this sphere, this space is called electric field of plus Q. This space is called the electric field of plus Q. What is the importance of, what is the speciality of this space? See, suppose you place a plus Q charge here. Here plus Q charge. Then what will happen? This charge will exert a force on plus Q charge. This charge will exert a repulsive force on plus Q. Then you place a minus Q charge here. What will happen? This charge will exert an attractive force on minus Q. Therefore, if any charge is coming in this space, this charge, the center charge, will exert a force on that charges. Therefore, this space is called the electric field of plus Q. Okay. Now we are coming to another point. It is intensity of electric field. We have studied about electric field. Now we are studying about intensity of electric field. Intensity of electric field at a point intensity of the electric field at a point. Usually it is represented by the English letter, English alphabet E. I will give the definition first. It is what is intensity of the electric field? Intensity of electric field at a point is the force. It is the force acting on a unit positive charge placed at that point. This is the definition of intensity of electric field. To understand this, you can take the previous example. You can take the plus Q charge here. Then this space is the electric field of plus Q. You can take a point here, A. Another point B. Another point C. Therefore, A, B and C are the 3 points in the electric field of plus Q. Then you can ask the question, what is the intensity of the electric field at A? What is the intensity of the electric field at B? And what is the intensity of the electric field at C? I told you, intensity of the electric field is the property of every point or each point in the electric field. Then you can ask the question, what is the intensity of the electric field at A? It is E1. E1 is the intensity of the electric field. What is the intensity at B? It is E2. Similarly, E3 is the intensity of the electric field at C. How to find out the intensity? I told you this is the property. Each and every point is having the intensity of the electric field. And how to find out the intensity of the electric field at A? For that, you place 1 coulomb positive charge. 1 coulomb positive charge at A. This is what is called a unit positive charge. Then this charge will exert a force on this 1 coulomb. This force is called the intensity of the electric field at A. Let it be 10 Newton per coulomb. Therefore, once you place 1 coulomb of charge at A, this charge will exert a force of 10 Newton on it. This is called the intensity of the electric field at A. I think you understood what you mean by the intensity of the electric field at a point. You can take what here E2 is equal to, suppose it is 15 Newton per coulomb. Therefore, the intensity of the electric field at B is 15 Newton per coulomb. What does it mean? The meaning is, once you place 1 coulomb of positive charge at B, this charge will exert a force of 15 newtons. Then E3 is equal to, suppose it is 6 Newton per coulomb. Same meaning, 1 coulomb of positive charge is placed at C. This charge will exert a force of 6 Newton on it. Therefore, next, to generalize, to make a formula for plus Q, you can take a point P here. P is a point in the electric field and E is the intensity of the electric field at P. To find out P, instead of plus 1 coulomb, you place a small charge plus Q here. Here, this plus Q is called test charge. It is called a test charge. And this is called the source charge. Therefore, this electric field is the field of the source charge. To find out the intensity of the electric field at P, you place a test charge. Then definitely the Q will exert a force on P. That force is given by, you can write force on plus Q is equal to capital F. Therefore, mathematically, what is the force on plus 1 coulomb? You can bring the Q here. It is equal to F by Q. Therefore, force acting on a 1 coulomb charge placed at P will be F by Q, and that is called the intensity of the electric field at the point. Therefore, what is the formula of intensity of the electric field? E is equal to F by Q. Therefore, the formula for the intensity of the electric field is E is equal to F by Q. The condition is where Q is tending to 0. Q is not 0. It will be very, very small. Why we are imposing such a condition? I will come to this one. Suppose to find out the intensity of the electric field at A, you are placing 1 coulomb of positive charge. Then what will happen? This 1 coulomb will exert a force on Q, and sometimes this force will be enough to change the position of the source charge. It should not happen. എന്ന് പറഞ്ഞാൽ നമ്മളിവിടെ 1 കൂളംബ് ചാർജ് വെക്കുന്നു എന്ന് കരുതുക. ആ ചാർജ് ഇതിൽ അനുഭവപ്പെടുന്ന ഫോഴ്സ് കൊണ്ട് ഈ സോഴ്സ് ചാർജിൻ്റെ പൊസിഷന് മാറ്റം വരാൻ പാടില്ല. Therefore, the force should be small. അത് കാരണം എന്ത് ചെയ്യുന്നു? You are placing a small charge, extremely small charge, and the force on the source charge will not be enough to move its position. That is why we are taking the condition Q to be tending 0. Mathematically, the formula for the intensity of the electric field at any point is given by E is equal to F by Q. F is the force acting on a test charge Q placed at the point. Okay. Now, what is the unit of intensity of the electric field? What is the unit? Unit is very simple. We have seen here the unit of from the formula. The unit of force is Newton, the unit of charge is Coulomb. Therefore, the unit of E is Newton per Coulomb. Newton per Coulomb is the unit of intensity of electric field. Now, we can discuss the intensity of the electric field due to different charges. First case is a point charge. Intensity of electric field due to a point charge. Intensity of the electric field due to a point charge. For that, you can take a point charge Q. Consider a point P at a distance R from the charge Q. Our aim is to find out the intensity of the electric field at P. Imagine E is the intensity. E be the intensity of electric field at P. You have to find out what is the value of E. For that, I am placing a test charge Q0. Q0 is the test charge placed at P. Then by Coulomb's law, the force acts on Q0 is equal to F. The formula is 1 by 4 pi epsilon 0 into Q1 Q2 by R square. Once you substitute the values, you are getting F is equal to 1 by 4 pi epsilon 0 into Q1 means Q into Q0 by R square. You bring the Q0 here. Then F by Q0 is equal to 1 by 4 pi epsilon 0 into Q by R square. What is F by Q0? It is the force acting on a unit positive charge placed at P. We have the formula E is equal to F by Q. Therefore, this is the E at P. Therefore, the formula for the intensity of the electric field at P due to a point charge is given by E is equal to 1 by 4 pi epsilon 0 into Q by R square. By using this formula, you can find out the intensity of the electric field at any point due to the point charge. E is the intensity at a point at a distance R from the point charge Q. Okay. Next, we are coming to the intensity of the electric field. Next topic is intensity of electric field due to a system of charges. Due to a system of charges. Say, consider a point P. Here P is the point at a distance R1P from a point charge Q1. Therefore, P is a point at a distance R1P. R1P is the distance between P and the charge. Then what is the intensity of the electric field? Let it be E1. It is directed like this. And E1 is given by the formula. E1 is equal to 1 by 4 pi epsilon 0 into Q1 by R1P square. R1P square. We have studied the formula. Intensity of the electric field is 1 by 4 pi epsilon Q by R square. This formula is applied here and is directed like this. Then you can take another charge Q2. Another charge Q2 at a distance R2P from the point. Then the intensity of the electric field is directly like this, E2. Then what is the value of E2? E2 is equal to 1 by 4 pi epsilon 0 into Q2 by R2P the square. Then you can take a charge Q3 here. Where the charge is Q3? At a distance R3P from the point. It will be directed like this. That is E3. What is the value of E3? We know E3 is equal to 1 by 4 pi epsilon 0 into Q3 by R3P square. Therefore, what is the intensity of the electric field at P due to a system of charges? Here the system is constituted by the charges Q1, Q2 and Q3. It is given by E is equal to E1 plus E2 plus E3 by superposition principle. Okay. Suppose there are n charges, then what will be the intensity? Then E is equal to the intensity of the electric field at P due to the n number of charges. Therefore, E is given by E1 plus E2 plus E3 plus etc. up to En. This completes the discussion of intensity of the electric field due to a system of charges. For the time being, we can stop here. We will come with another topics in the next class. Thank you.